Good morning.
Good morning.
Good morning.
Hello, everyone.
Hi, Anu.
Hi, Anna.
Wait 1 more minute before we get started. All right, it's 8:03, so let's get started. The first thing I wanted to go through before we get to the meat of the matter today is the documentation. I feel like we've made a fair amount of progress here, at least in knowing where stuff can be put and everybody doing it in a somewhat similar fashion. Nobody's dictating how your Google Drive should be set up, but Marek gave some excellent suggestions, and it just would be easier possibly if you did some along the similar vein. But it's all power to the Workstream leads. So the way we have it is the top level is the OCP official page. If you go and look, you will notice that Kevin from the OCP has removed all the information about the call schedules. You will have to go to the wiki page, which is the top right link on that page. And that'll take you to our regular wiki page, which I believe most of the Workstream leads have permission to edit. I just cut and paste into the chat window a wiki cheat sheet. It's not a very nice editor. It is what it is, but it's the simplest way to get ahead. So that wiki page then can have links to each of your individual Workstream wiki pages, which is what we had talked about a couple of meetings ago. And then in that wiki page, you can put in the Google Drive that each Workstream has assigned, and we figured out what those drives are, and everybody has access to it. There you can create subfolders and divide and conquer as you choose. So at least we have some kind of method to the madness. Further information will come about how I think there was some automated recording stuff that Marek showed, and David had some questions, and I'm not sure we have an answer to whether those links are forever available, Marek.
Yeah, that's probably a question for Kevin from OCP to help answer.
Yeah, so that was a good point. If you provide a link, I don't know if that stays forever. So we'll figure out how to keep the recordings safe going forward, and so people have access to it. For everyone in a Workstream, you may not have permission to access the Google Drive just because you're part of the Workstream. You will have to make a request. Just by clicking the drive, it'll request for access, and that goes to the workstream leads who will then grant you permission. So that's our high-level method to the madness. Any questions on documentation?
Yes, I know. So to create a wiki page, I need to talk to Kevin.
If you're not able to edit it, so on the wiki page, there's an edit. I think it says edit source on that page. If you go there and it says you have no permissions, that means you don't have credentials, and you'll have to ask Kevin.
Okay.
I think Itai had also asked, there was some kind of a visual editor, right, Itai?
Hi. Yes, at the moment there is no, but
Oh, it's not installed in our environment. Okay.
it's not installed, but he said he will install it, so it will be easier. Today I copy the text to VS Codes, and with an application I edit it there.
Yeah, if you have a simple way of doing it, if you could share it with the group, because it's not something most people don't deal with wiki pages.
Yes.
And it's not a pretty way of editing it. So if you figured something out, Itai, do share it
Sure.
with everyone else, including me, because
Okay.
I've got to start mucking around with that page too. So
Sure, I'll send it over.
thank you. So David, we don't have a good answer for you that it's a nice little editor and you can do it. But number one, you need to get permission, which Kevin will help you with.
Okay.
Any other questions on documentation? Okay, if not, I'm going to hand it off to Marek and Raghu. And I just wanted to say, Marek is actually, this is probably one of the last few meetings, right, Marek, that you're going to
Yes,
participate?
exactly. Yeah, I accepted a new job in the same company, but not focusing on chiplets anymore. So I'm looking to hand off the business group lead to somebody else to continue the work.
Yeah, Marek's been phenomenal. I for certain will really miss you and your organization, and the fact that you gave me deadlines really enabled me to get my job done. So I do appreciate it, but it's all yours now, Marek and Raghu. Thank you.
Awesome. Okay, thanks. Let me go ahead and share my screen here. All right. So today, Raghu and I want to talk about a proposal that we've been working on in the business group, which is focusing on using System C simulations for chiplet compatibility and selection. So in the first half, I'll give a bit more of context of why we think this is a relevant idea, and then Raghu will talk more about the proposal itself. But before any of you get bored, I want to give you an executive summary so that you know what we want to get to you. Our proposal is about developing a System C simulation framework for chiplet architecture interoperability testing. And we want to build example chiplet systems and benchmark them using models from existing chiplets of chiplet vendors. Our ask today is for you to give us feedback on what you think about this idea, and also to let us know if you want to collaborate. And the benefits of working with us is that it helps raise the visibility of any chiplet vendor that wants to contribute and possibly help with modeling. And also, I think this is an important step for possible potential chiplet customers that through this work will be able to understand more easily how they can check interoperability. So let's get started with a quick background here. I'm sure most of you have seen this kind of chart before, which talks about the adoption of chiplets. It all started with single vendor solutions, which are still the dominant source today of chiplet systems in the market, where one company controls everything about a system, including all the chiplets that are in it. So at that point, you don't really need much standardization. However, more recently, we have seen both an emergence of multi-vendor solutions, where you have a couple of companies partnering up to provide systems, as well as an emerging trend towards an open ecosystem. And here really, this is, I would say, the end state that a lot of people would like to see. And the dream is that at some point you're able to plug and play multiple chiplets from a marketplace that just work out of the box. But of course, it's a long road to get there. One of the steps that we took as OCP is to launch this Open Chiplet Economy Marketplace last year. That was done part also with the business group. And the focus here was really to put together one page that reflects the entire economy, not just the vendors that may have chiplets available, but also have a place for all the other vendors that help create this ecosystem by having tools, software, IP packaging, and other things available and listed here. Now, I want to come back to one data point that gave us pause last year when we were hosting the second Chiplet Business Challenges workshop. And we asked companies, well, what are the main challenges that you see? And the top response from the 14 companies that we talked to were that there weren't enough standards out there to fully specify a chiplet system, and that interoperability was a big question mark. So after doing some other work in the business workstream, such as a white paper that we wrote on kind of explaining what it takes to build a chiplet system, we figured that it would be a great way to start here because this is obviously the top concern. So to ground everybody in what we were like how we're seeing this marketplace and the scenarios that we want to enable, it looks something like this. In the future, or even now, you have customers that have their own ASICs and are building chiplets on their own, but they don't want to build the entire system. They're looking for chiplets from a marketplace that can help with certain subsystems that they may not be good in or that may be too complex for them to build. And using this marketplace, they may want to build systems that combine their internal chiplets with some open chiplets or third-party chiplets into a system, or they may even choose to compose a chiplet or a system out of external chiplets altogether. And as I mentioned, the main benefits of doing this is that you can now leverage the work that other people have done, where you may be too resource constrained or where you may not just have the right expertise to build a chiplet like this. And of course, it also translates into an accelerated time to market for your product. Now, what are the big challenges when doing this? When you are looking at other chiplets that are out there, you have to ask yourself a couple of questions of whether that chiplet is going to work in your context. First, you need to know what chiplets are out there. So that's something we addressed with the marketplace. The second piece is that you need to understand the die-to-die stack that you're envisioning and whether that's compatible with the chiplets that you're looking at. So that's something like understanding if you have the right PHY, be it UCIe, bunch of wires, or something else. Looking at whether the right link layers are supported. But then also importantly, there's a question about architectural compatibility. Whether, for example, memory access is handled the same way that you're envisioning for your IP, or whether interrupts are handled the way that you need them to be. In order to address that question, we are thinking that it would be nice to have some kind of virtual prototyping available that can help answer these questions quickly before you dive into an all-out development effort. And that's where I want to hand this off to Raghu.
Hey, Marek, can you hear me?
Yes.
Perfect. Hey, Marek, thanks for setting the stage very well. To reiterate, our vision is to grow the multiple vendors chiplet economy that Marek showed in the second or third slide. And one way to grow that is to increase the number of participants and also the number of engagements at the top of the funnel in the early stages of the design cycle. And this slide is kind of roughly laid out from left to right that follows a typical design cycle, where we're looking at the front end of the chiplet development flow. And then you also have the back end phases that eventually the thinking is that the more number of engagements that we can nurture at the front end, some of these engagements will graduate to next phases of implementation and back end flows into a more kind of vibrant revenue generating ecosystems, multi-vendor ecosystems. And many of these efforts upfront may not, but that is okay. We want to build a foundation or a library of architectural compatible chiplets that will overall speed up evaluations for faster and lower effort considerations. And looking at the problems and opportunities right now, and some of the data points that we got in the past, is that identifying vendors and even specific products is very labor intensive and high effort is required. There is not much kind of consistency, and there's not yet any automation. And how do we scale this across many chiplet vendors that we want to be shopping around with for possibilities of engagements? And then possibly even looking at number three, possibly many are already doing it today, but is it being consistently applied? And maybe some of them are doing it in a suboptimal way. So can we be the forum to bring in more best practices that makes it more efficient for all and makes it a more efficient marketplace in general? And lastly, is there a way that we can also extend this to evaluate the value proposition of performance, power, area, and cost? Eventually, that's what determines whether some of these compatible chiplets can go on to become real revenue generating products in the back end, after the back end. And if you can estimate the value proposition early in the design cycle with higher confidence that is defendable and more acceptable, then that's more power for more business that can be graduated for the next phases. So the middle box is the what we are proposing. And I have got the next slide will go in more details, but we want to cover the benefits of we are proposing a virtual chiplet prototyping marketplace along the lines of virtual prototyping that is prevalent in the industry today. And it's also an evolution of the term of OCP marketplace that Marek mentioned, and which is a listing of products right now, but not yet the models, right? So can we evolve that into something more substantial to take it to the next level? And getting into the details of OCP is in an ideal position to offer a vendor-neutral framework that encourages large and small companies to list their models, kind of leveling the playing field for all. Two, this allows testing and listing of architectural compatible products, speeding up the discovery and what I call quote unquote soft trials early in the design cycle, and thereby eliminating some of the later stage dead ends. And three, we are moving from like spec sheets reading that's listed to architectural models, like essentially moving one level up. And can we automate and scale? And so that way we can test out with a larger pool of offerings for faster evaluations and high confidence decisions. Four is basically the best practices where we are pooling our knowledge during this phase. A lot of this knowledge is embedded in many of these peoples and many in the industry, but can we pool our knowledge so that, hey, we're developing the best practices that can be adopted by all, and then also by the next wave of participants coming in, and generally making this process more efficient. Because after all, if we want to build a vibrant multi-vendor economy, we need to also make this process more efficient in general. Five, some of these things can also be developed. Again, think of this as being phasing out over multiple kind of weeks or months, right? So, but we want to develop some reference designs, which should be a select combination of some of the chiplets already there. And that could provide very good marketing materials that we can advertise on our OCP sites and global summits. And that will also provide visibility for the players participating in this effort. And six is can we develop some more better methodology of estimating the value proposition, so that like converting some of these performance, power, area, and cost, and can we have like a much more better understanding of the business value that could be acceptable by many people if you follow a methodology. And lastly, as the overall, the seventh bullet point is basically overall. This is the effort is to find the right matches faster, which basically means faster time to revenue, larger pools to shop around with, finding better design fits. That basically means higher revenue, and also strategically outsourcing some components that some people may choose to decide, and that basically lowers the NRE. All the good things that chiplets, all the benefits of chiplets, the value proposition of chiplets. How do we kind of bring that to fore? Now, in large, I think something that Marek mentioned, I want to touch upon that, right? In large companies that are further along in the chiplet journey, the 1 and 2 that Marek showed, a lot of these things might be a well understood internal process, right? This has been evolved over many generations, and they're now building chiplets, and there's a lot of tribal knowledge. They have intimate understanding of their own dies and control their own IP. So maybe a lot of these things happens kind of almost autonomously. And the question is, can some of, in a multi-vendor environment, can this be brought to some central point, right? Kind of a lightweight central point that some of these things can be tried out in a kind of a open kind of virtual chiplet marketplace. And also we are trying to level the playing field, right? So we want to have the large vendors participate, but we also want to level the playing field for some of the smaller and medium-sized players. So this is kind of a step in that direction. So I'm going to cover the framework in the next slide, but the next steps is to talk to some of the, engage some of the stakeholders who will immediately benefit from this virtual prototyping initiative. I mean, these could be some of the EDA vendors, IP vendors, the chiplet vendors themselves. And the success will depend on the participation level. I mean, I guess OCP or OCE itself, or even the business workstream itself, will not be able to tackle a lot of these things. We can be at best a program management office. But we definitely want to see what the interest level is to build such a community. And so we want to engage the ecosystem vendors, get their feedback and have them shape the strategy, right? And thereby the initial few will also get visibility in the ways that I mentioned before and get a head start. And the role that OCP and OCE can play out here is kind of a more of a neutral body where we encourage all big and small players to participate. And besides supporting this framework and providing some program management, I'm expecting the OCP and OCE specifically will provide the marketing muscle through our global summits and newsletters and webinars. And so that again drives visibility for the participants to engage in this, for them to also to get visibility and demonstrate their capabilities. So let me now move to the next slide that dives one more level of detail into the framework. And this shows the possibilities around this framework and how we roll this out and what kind of feedback we get and kind of fine tune it. That's very critical, but this is what our thinking is today. And starting at the bottom left, again, kind of a representative sample of vendors who are hopefully some of them or many of them will want to be participating in this initiative. And the big green box, think of that as is now kind of branded as the virtual chiplets prototype marketplace, but essentially we can think of this as a repository or a GitHub repository. I'm not trying to get into the details right now, but just think of this for now as a repository of System C models. System C, again, by the way, for folks who don't know, is an IEEE standard for many years. And possibly many models are built on System C as starters. And so this repository can be a good place to drop in some that details to be decided how and kind of what level of security and privacy, but hold that off for a future discussion. But eventually what you want to say is that, hey, there are a lot of these chiplets that have been tested for compatibility, architecture compatibility, and basically it's kind of a head start for folks to finding partners. And so we can create a matrix of, hey, these are all the compatible designs and what level of compatibility have been tested, right? So over time, we can test the compatibility, build this matrix, and essentially that can be done in two ways. The first one is almost two ways and almost two different levels, right? The simplest one would be a simulation, which is still 50x faster than System Verilog and RTL simulation. And thereby we can call it like a quote unquote lower effort and give some medium level of confidence that, hey, okay, architecture level is compatible. This based on TLM, which is transaction level modeling. So hey, at that architecture level, at least these two chiplets can work, or maybe more, right? 3 or 4 chiplets can work together. And what I expect is that this will run test benches and maybe parts of benchmarks. So that's the level of comfort we can get out there, or confidence we can get out there. The second more interesting use case would be demonstrate a higher level of compatibility on FPGAs, and these will obviously run at much higher speeds. Still slower than the final product, but it's much faster. And more intensive benchmarks and workloads can be demonstrated on that. Again, we'll pick a few of these use cases that the vendors may say, hey, it makes sense. I want to be like even more compatible, even demonstrate more compatibility, right? And later can be, so besides the benchmarks and workloads that can be done, they can also be a staging ground for hardware software co-design, should we go down that path. So then, okay, that's the left to right path, right? Assuming the System C models are created or are available. The other path that we have been thinking of is that for products already with System Verilog models, and maybe some of these products are already in the market. Again, moving to the right side of the slide. And maybe the chiplet vendors want to expand its adoption and shop it around and say, hey, I have a chiplet, I want to shop it around and see what it is, right? There is a proven and a well-used open source tool. It's been around for 10, 20 years called Verilator. And that converts RTL to System C. So we can bring it back. Again, if the chiplet vendor so decides, we can bring it back and drop that System C models into the marketplace. And again, go through the same process of compatibility testing at simulation level or FPGA level. And hopefully that can help the chiplet vendor discover more opportunities to do more business and more revenue. And the another potential path, the last potential path I want to also highlight is for design space exploration. And what one can do out here is that the System C models, one or more of these models, can be run through high-level synthesis. Again, pretty much all EDA vendors are providing some form of high-level synthesis for many years. And I think my understanding is that it'll provide a reasonable RTL, may not be ready for production, but again, it's a reasonable RTL that can allow us to estimate the power, performance, and area and cost. That can give us a little bit more confidence on the design space exploration that can drive the business, that can kind of be used for business value discussions. And this is where I think the chiplet value of, hey, should we outsource these non-core functionality or do some feature enhancements with third-party chiplets, or maybe scaling some chiplets on older nodes, or doing aggregation. Maybe some of those what-if scenarios can be done with slightly higher confidence than what is being done today. So again, to reiterate the deliverables that is being mentioned on the top right, the OCP and OCE I'm expecting will support the basics of the framework, and in return will create this vibrant economy that we all want to, multi-vendor economy that we want to go through. And OCP will benefit from nurturing these vendors, and which will become legit ecosystems. We want to then deliver some of the architecture compatibility of chiplets so that all vendors can expand their market presence, find the best partners to go and work with, do some best practices for early stage evaluations that will, hopefully some of these will become into backend developments. Again, automate and scale and make it more efficient. Provide some reference designs that will again provide further clarity for next wave of participants. And kind of lastly, the value propositions of power, performance, area, and cost that can drive business case. So that's kind of the deliverables that we see that will benefit the community overall. I think that's my 2 slides, Marek and team.
Yep, thanks, Raghu. So now we would like to hear from the audience what you guys think about this and what your experience has been with this question of making sure that chiplets that have been defined, that they're actually compatible with one another at kind of a deeper level that's more than just the PHY.
Well, I mean, it makes sense to me. I guess when I look at it, it's like we need a whole nother set of specifications because you have to make the models compatible, right? So it's a whole nother level of, we have to define a framework where you can plug these things in together and they actually talk. I mean, TLM is just, it's like okay, saying they're both written in Verilog. It doesn't mean they're remotely compatible, right? Because you've got to get lots of things. And what level are you going to do this? Is it just transactions? Is it bus level? So I think there's a lot of peeling that we need to do, and you have to decide if, is this another work stream, anew that would have to define this? I'm not sure. It seems like there's a level of specification required.
Yeah, that's a really good point. And I guess our thought was, by having multiple vendors that have an interest in this collaborate in the space, that at least anything that can be pre-competitive and anything that can be in an open setting like OCP, that at least that would lead to maybe some like alignment, because everybody's talking together on how to get this done.
So, Mark, this is Arvind. I could say from experience, I think this would be of really high value. I think we have struggled also with these compatibility type questions. And of course, the whole chiplet, ecosystem is still in its infancy right now. So it's very hard to like have a lot of test cases that you could put into this. I think maybe one or two questions I might have is, I'm assuming this then would have compatibility with the various emerging open standards. So you could do this with, 2 UCIe chiplets or 2 bunch of wires chiplets or something. I mean, is that, I would assume that flexibility would be part of this?
Yeah, very much. It's not really, I mean, it's really, the goal would be to say, I think it's easy enough for people to at least ask, like, well, what PHY are you using? But have a framework that can abstract away from that, so that even if there are vendors that choose to use kind of a proprietary standard, that they can still have a way and kind of a blueprint on how to do the modeling.
Yeah, and I also echo that, Arvind, in the sense that we are not going to dictate, at least through this framework, we're not going to dictate specific technologies like UCIe or a bunch of wires. I believe
Right.
OCP or OCE is open
Yeah.
forum. But again, it all depends on who comes forward, right? The more people come forward in UCIe, great. More people come forward in bunch of wires, great. So there'll be a little bit of that kind of momentum where we see the momentum coming in.
Mm-hmm.
Yeah, but we're going beyond the level of just PHY compatibility, right? So it should be all inclusive. I understand what you're saying, Raghu. It depends on which players show up first.
Yeah.
So
But it's all inclusive. It's all inclusive, absolutely. I was just trying to say, okay, by the way, I'm no way I'm trying to exclude anyone. We are trying to exclude anyone. I was just trying to say that sometimes this will just go in who shows up. That's all I was trying to say. Sorry,
Right.
Anu, I'm not sure if you wanted to say something more, but I just.
So Raghu, I'm going to try to peel this a little bit here and just, what is the ask of people who have chiplets? And then who is responsible for building all of these workspaces, so to speak, right?
Correct.
So let's start with your green box there. We've got a number of chiplets there. They all follow some standard. I'm not entirely certain what, but what you would require of these guys is to provide these system C models for multiple different pieces. I mean, you've got EDA, IP, chiplet. Could you just explain that to me a little bit more?
Yeah, we're trying to see how this can be inclusive of the multiple players that we have in the open chiplet economy, Anu, right? So, I mean, fundamentally, the system C models would come from some chiplet vendors themselves, or maybe
Right.
from IP providers themselves, right?
Right.
And the reason I'm calling out EDA is that a lot of these has to be run on some EDA tools, right?
Right.
So when I did a scan of the landscape of the industry,
Yeah.
I see that pretty much all EDA vendors, like Cadence, Synopsys, by the way, I'm no way I'm singling it out, but it could be any of the top guys, Siemens, and et cetera, they are supporting some form of System C simulation, right, and FPGA prototyping, right? So they also have to step in, right? And as I said, we want to be the kind of the matching house or clearing house, like we as an OCP, OCE, to say, hey, let's say two chiplet vendors. I think going back to Marek's slide, right? A and B and C, and say two or three chiplet vendors want to come together and say, hey, you know what? I want to prove, pre-prove, if that's a word like that, right?
Right.
Compatibility, right? And okay, now we have to pick some tool. Okay, maybe they'll say, hey, Cadence steps up, or Synopsys steps up and say, you know what? For this trial evaluation, I'm willing to give some minimal license. And I'm assuming there'll be a little bit of a tool aspect of this to say, hey, I'm trying it on Synopsys tool. Of course, the chiplets will also work in some other tool, but we also will need that tool, right? So that's what I was trying to say, that we want. And by the way, a third set of chiplet providers might come and say, and then say, hey, I want to try this on Siemens or Cadence. So that's how I'm thinking about it. But as I said, all of this is our 3 months of kind of vetting it out within our business team forum, and a lot more improvements and comments, feedback will come, like Rob mentioned and Arvind mentioned, right? That we need to go sort out. But that's hopefully this response will be enough, Anu, to answer your question, but I'll be happy to answer more.
No. I think that makes sense. And so now going to Arvind saying this would be really useful. So Arvind, the way you would use this is you've got your own chiplet at IBM, and then you want to use 4 other chiplets which are in this marketplace. Let's assume that they support this System C models. And now you can take your chiplet, which also supports those models, take these other chiplets, and then run. Of course, the devil's in the details, as Rob said, but you can run some set of simulations to give you some confidence of feasibility, compatibility at a very early point. Is that where your value add lies?
Yeah, I think you summarized it very well. I would add, I think you included it, is at this stage, because there really aren't a lot of chiplets out there, you might be working with somebody else. So even having that pre-validation during the design phase would be of high value. Because we're designing a chiplet, somebody else is concurrently designing another chiplet that we would like to be compatible with. But if we had a tool that would help us assure that will happen, I think that would give us much greater confidence and would also guide our design process.
Okay, so I want to take another step back and actually define this word compatible. We've got work streams that are looking at interoperability, system level interoperability between chiplets, which is sort of addressing the same space. But when you say compatibility, this is electrical, physical, just functional.
I think it's all across the stack. It's all the way up from the physical layer through the die-to-die, the parameter management, and then the required protocol.
Yeah, and that is something. So at the very minimum, I'm thinking, at least based on what my read on the in the industry is like architectural or functional and transaction level modeling, right? Now, if Arvind's, based on Arvind's experience, if we can go deeper, fantastic. Love it, right? But so Anu, to answer your question, at least I had not envisioned it, but I'm totally open to thinking more broadly. I not envisioned this going up to the kind of the electrical level and all that. Or at least I think the slide that Marek showed was the 4 layers he showed. And I think that's a protocol layer, adapter layer, file layer. Right now, at least we want to start out at the architecture layer. And again, if Arvind says, hey, you know what, we can go down more, so be it, right? But at least we want to start at thinking at the architecture layer right now.
And sorry, the architecture layer, and just to be very clear on the definition, where is that in the stack? Is that?
Can you go back to that slide?
Yeah, Marek? I just wanted to make sure.
Yeah,
sure. No, absolutely. Again, but all of this is subject to more discussion, right? In the sense that so go back. Yeah, this one. Yeah.
Yeah, but that. Oh, so okay, so that's above the protocol adapter.
Yeah, that's kind of a vague catch-all, right, for you guys at this point?
Yeah. I would say so.
Yeah.
Okay.
And by the way, Anu, just to go back, I mean, if there are other work streams that are kind of, we are overlap there, we'll definitely be respectful and try to focus on where it
No,
makes
no,
more
absolutely.
sense.
Which is actually the reason I asked you and Marek to present today, is because I wanted the other work streams. The leads are here to see like how all of this fits in with each other. It's kind of many pieces of a puzzle. Which work stream is working on which pieces and how they click together almost. So that Durgesh, Itai, and Rob are here. Any thoughts from you guys? I know Rob already had some, comments on the details and compatibility. Model A and Model B built with the same software, not necessarily going to talk to each other even. So, fair point.
So at systems level, Anu, that's what exactly you're trying to address, what the problem was brought up today. At systems level, how they are going to be compatible, given they are different vendors.
Yeah.
Sorry, Durgesh, I think, I mean, absolutely, if you're solving this, that's great.
No, at the
I mean,
systems
actually
level, not, yeah.
Yeah, so we want to actually, when I know my question asked this a couple of weeks back, I think my response was that we want to be at the front end to feed in more chiplets to your work stream, right? And we say, hey, these 2 or 3 chiplets are compatible. I mean, we'll have hopefully many more sets of compatible chiplets, and thereby it provides you a larger, richer portfolio of compatible chiplets to test at multiple layers at the system level. Is there any version of System C simulation and System C repository that you guys are already thinking of?
I think that in the system work group, this is what we are trying to define, and what you are suggesting is a tool on top of that, which will make sure that if someone wants to be compatible, this is a tool which will enable them to do it. So it should be included the definition that are done in the system work group, but this is I think it's a good tool for checking it or confirming that.
Yeah, I think
Cool.
I think that the systems group is asking questions like, how do these 2 chiplets even come up, right? How is this security going to be addressed? Things like that, which a lot of people are not addressing in the standards groups today, right? So we're coming at it from that angle. And I think the business group is coming at it also from even a higher level, which is, hey, we did a survey of all these potential users, and they're like, we're confused. Even within UCIe, there's different standards and different implementations, and two people trying to build the same spec and may end up with something different, right? That doesn't actually talk to. So I think that this is not just the purview of one group or whatever. I think this is sort of this is an industry problem right now, and I think that it is good to push for, hey, let's see if we can standardize on some models. Also, if we can actually standardize on what are the key system items that need to be covered, and do it in a way. And I think at the last systems group, we were talking, hey, try and be sensitive to the fact that, it's not just for a very high-end HPC device. We need to cover in the systems group. We need to be able to say, hey, you've got sort of a simpler device. You can have the overhead of a massive amount of system level stuff. So I think there's lots of work going on, and it's good to see that, right? Because the questions are being asked: how are these chiplets actually going to talk to each other and work, right? So you're going to need somebody as an end customer. They're going to need to be able to get something to look at that, right? And the systems group, I think, is addressing, okay, how do we actually do this, right? Forgetting the standards, how will 2 chiplets talk to each other at a lower level than a customer looking at it for. So there's 2 points of view here, but we're talking about the same thing in that sense.
That's well framed, and I said definitely Durgesh and Itai. I mean, if there's any, I guess, any overlaps or any kind of connection points that this initiative can do, definitely want to stay synchronized.
Maybe also coming back to Anu's original question on what our ask is, at least the way I would think about it is, as we just heard from all these comments, we're pretty early on. So we would love to have further discussions with vendors in the space, be it like IP or EDA or chiplet vendors, on how they themselves, like from a kind of like running a business, how they're thinking about it, like what they tell their customers when customers are asking, well, is your chiplet compatible with what I want to do? That is kind of, for us, I would say, more discovery and understanding the kinds of, like, say, tools that people are currently thinking of, to understand is the tool that we're proposing even the right one. But then assume it is, it would be helpful to, if vendors already have system C models of chiplets, would be great to be able, even if it's kind of like a somewhat stripped down model, like something that can be shared in a more public forum, that would be helpful to like basically try that out and see if we can prototype putting together systems with a number of system C models, or also collaborating with vendors to create these models, and also think about like what should the structure of that model be. And then, as in the business group, we don't have the expertise to actually run all these simulations. So I think we would also be looking for collaboration with EDA vendors on working with us on basically trying this out, and in the end coming to some kind of guidelines that we can present to a broader group and say, like, this is maybe how you would get started on building such a virtual prototyping marketplace.
Yeah, well said. I think, and so just go to the next couple of slides later on, because just to clarify what Itai is saying, or to go back, can you go a couple of more slides further up? Sorry. Yeah, this one. I just want to,
okay.
yeah, this one. So just stay there for a minute. I just want to say that it's not like one tool we are creating or something, right? We are just hoping in leveraging a lot of what's already available in the industry and what many companies may already be doing with System C, right? I think simulation that is shown as one, and FPGA prototyping shown as two. I think is like kind of well accepted practices that many companies are already doing. So we are not trying to create any other new tool. Now, the critical thing that we may have to figure out is to show compatibility. What are some combination of test benches to curate, right, or benchmarks to run to say, okay, these are compatible, at least at the architecture level, right, starting out there. And that's how I see it. We're not trying to create a tool. I think just mostly trying to create a repository or a marketplace where folks can come in and kind of share what they're comfortable sharing and say, hey, you know what, I want to test this out with other chiplets at the architecture layer.
Raghu and
Yeah.
Mark, have you considered using IP exact for describing the IP?
Actually, I would love to know more. I have not. No, I didn't come across that. I didn't come across it personally. So if you can send me a link or.
Okay, IP exact is like an XML format which used to describe the IP, IPs. So I'm not sure if the System C is already doing the same thing, but maybe it's a combination. So there is a standard of IP exact which describes the registers, the interfaces of Verilog IP, which is already used by many of the vendors.
Oh, okay, it's good. Yeah, I think
I'll send a link.
Yeah, send a link. Yeah, I think so. The System C and the simulation, I think, to us does some level of event-driven and transaction level modeling and of some test benches and benchmarks, right? So I think so that's what simulation does, but I would love to see what this IP exact also does.
Just one question: this IP exact, do you need EDA? Like, do you need a specific EDA proprietary tool to run this, or?
Itai, I think it's a question for you about IP exact. Is that open source, or does it need some licensing?
No, it's an open source.
Yay, Patricia, there you go.
Yeah, thank you.
But it's not a simulation type tool, right? It's a description tool.
Yeah, it's
Yes.
an IP. It sounds like it's a.
It's
IP
just like what's the one that OCP's
CD,
pushing?
is it like CD XML?
Yeah, it's like CDXML. It doesn't help you to actually run something and see, you know, whether it will work. But
It basically creates a
yes.
machine readable format of your IP
yeah.
description.
Yes.
But then
Exactly.
what do you do?
And there are tools
documentation.
which, for example, can read several IP exact and then do like prepare like an integration top level from out of it. But again, if there are other format for doing it, that's okay. But
No, it's XML format.
this is the one I am familiar with.
Yeah, actually, interestingly, I'm wondering if even our CD XML format can be run through that, right? Because then we can be aligned to our OCP, OCE formats if possible. So maybe what we need to see is to say, hey, can CD XML, can we drive CD XML through this IP exact tool? And that could be like almost like a front-end processing before you even get into simulation. So it'll like say, hey, if these two guys don't even match on these basic registers and bus wires or whatever it is, no point even going and trying simulation on this.
Raghu, I have a question.
Yeah, go ahead.
This is fascinating work. So in an ideal situation, what would you need OCP to provide support with to maybe move along this? And I'm not talking about just creating new activity in OCE, but more like, do we need something from OCP in some material format?
Yeah, good question, Jawad. At the very beginning, I'm wondering how formal we can make this, Jawad, having some OCP muscle behind this to say, again, I'm thinking totally open to this, right? So I'm thinking, say, if I should reach out to vendors and let's say, hey, and OCP says OCP is backing it through some RFI, like a request for information or a call for participation, right? I'm wondering, and then say, hey, OCP comes and says, hey, if you participate in this initiative, we will give you some, if this goes through, we will give you visibility through some of the global summit presentations or marketing material and all that we'll post on the marketplace, right? So having that OCP backing and OCP support, Jawad, I think is very critical, right? Just me and you just going and shopping it around, we can do that and just socialize it. But I think if we bring in the OCP support to say, hey, OCP is behind this and we want this to happen, right? That will be will go a long way to make this happen.
So I have a thought about it. I'm gonna talk to Cliff, but I think we probably should take this to the incubation committee and present there. But before then, we should probably discuss it a little bit more at this forum to think about some concrete asks that we would expect Bijan or those guys to help us with.
And sorry, and also the another concrete ask that will come out of this is at least to have some kind of repository, I'm calling it right now, like a GitHub repository or a OCP branded repository. Maybe it might be private for some time, and maybe we'll open it up as we see deemed fit, right? So it's similar to what the marketplace that we have today, right? Where we are just listing all the chiplets vendors, but can we take it one level higher to make it more of a GitHub? By the way, there is precedence out there, right? There are many System C models that are posted by even some leading vendors like NVIDIA and many other vendors, right? So there's nothing new. It's just a question of, can we have it OCP branded and OCP hosted, right? So those things I think will be an ask that Jawad, we need to go and I guess I totally agree. We need to discuss in this forum, your forum, get your feedback, and then we can see how we can go and shop it for the other.
I'm still in my mind not completely clear between the system work group and here where the lines are. If the lines are fuzzy, that's fine. I just want to have in my head at least, have a clear idea of what the two asks are different or similar, or one can work with the other, and somehow it's not terribly clear in my head. Maybe someone else has a better way of framing it. I understand what Cash was saying, that same goal but approaching it from different ways. But as a sort of the amount of work that needs to be done and the different asks, it needs to sort of be clearly scoped out, so we're not repeating ourselves or we're not doing unnecessary work, or just so if someone has a better understanding, I'd appreciate
Yeah,
it.
I mean, the thing is, in the systems group, we have to make everything sort of bit compatible, right? It's like you have to say, I'm going to set this bit and I know it's going to do what I expect it to do. In this thing, it's more of probably most of your simulation is in the higher level architectural things, which is, okay, I want to fetch memory from this other chiplet. Am I getting enough bandwidth? What power am I burning?
I see.
Right. I don't really care if I booted it correctly. I really don't care about is it secure? Am I, it's really more at the architectural level. That's the way I think of this, because that's
Correct.
usually where you're trying to, when you do this initial evaluation, it's like, will it solve the problem I want it to solve? Not does every bit, nut and bolt
Okay.
all fit together. That's my thoughts. I don't
No,
know if that's,
absolutely. I
yeah.
think no, Rob is like
No, that
absolutely correct.
definitely helps me. So when you talk about, does this bit do what the damn bit is supposed to do so that it flows downstream and upstream correct? That's the details, the devil in the details of the system level group, versus here we're looking at a higher level simulation for a give and take between chiplets to see if you're getting what you get as expected.
Yeah, because if we try to do what we're doing in systems in this thing, you basically just have RTL level simulation between all the chiplets, which is, people have to do that anyways, but that's probably not the point of this initial evaluation, right?
Correct.
Well, yeah, and I doubt you're going to get RTL from a chiplet vendor, right?
Well, I mean, if you get a system C model, that's exactly their RTL. I mean, it's going to run the same speed as their RTL. If you use Verilator to convert it, that's great, but it's basically runs the same speed as RTL.
Okay.
Right. So it's you need all the bits and bytes and everything to make it actually run, as opposed to if it's a higher level model, it's like, okay, I can just get some TLM. This TLM stream is fetch memory, not AXI bus of 256 bytes wide that has this certain,
Correct.
yeah.
Correct.
Okay, no, that sorry, that really helps me understand the clear distinction between the two. So I think as a team, we've got to think about this a little bit more, and maybe Raghu, now that maybe it's some of it is more up to you than Marek at this point, define the scope and the ask a little more clearly, as Javad was saying. So we might need to have continued discussions, which I think with what Marek planned to do at the 9 o'clock meeting anyway.
Correct. Yeah, totally. I said, I think based on Anu's encouragement, thank you first, all of y'all, for listening in and commenting and providing feedback, right? I think based on Anu's encouragement, we wanted to at least come and show it earlier rather than later to sort out any kind of overlaps or conflicts. So we will take the feedback here and work with Anu maybe in the next meeting or next week, and then work with Jawad, whatever the right point is for us to interact, and also stay in close touch with systems group. Again, by the way, we're not trying to recreate anything that's very good thing happening in systems group. We're trying to be more complementary to that.
Yeah, no, understood. And maybe Arvind, if you have a chance to join the 9 o'clock meeting, that might be useful. Thank you so much, Raghu and Marek, for sharing today, and we will continue to have discussions. We have 1 minute left, and I wanted to thank Quinn. Is Quinn still on the call? Maybe not. So Quinn has been kind enough to allow us to use the CMU campus at the NASA Ames Center to have the die-to-die phi metrics workshop the day after ChipCon 2025. So that is the July 9th, I believe. I don't know, is Kevin here? Sorry, I've forgotten my dates a little bit. Hold on, it is going to be, no, July 11th, most likely. ChipCon is on July 8th and 9th and 10th, I believe. So July 11th. It'll be in the Bay Area at the CMU campus, and we really appreciate it. we're planning on the program. It'll be similar to last year, but we'll send out details and have a quick discussion in a week or two, Friday meeting. Thank you, everyone. For those in the US, enjoy your long weekend.
You
Bye.
too.
Right.
Bye.
Thanks, everyone. Bye-bye.